Hello everyone, it's a pleasure to present for you our investigation entitled Exergy and Economic Analysis of Modified Mixed Mode Solar Injera Dryer. This 9th AI ICAST 2021 conference. The authors of this article are Senay, Teshome, Dr. Abdulkadir, Hassen, and Dr. Kamil, Adem. First, I will introduce the content of this presentation. Introduction, literature review, objective, methodology, and result. Finally, conclusion will be presented with this order. To start with this introduction, injera is the most important meal in Ethiopian culture. In drying, injera helps to preserve injera by avoiding mold spoilage and infestation. Commercial enterprises use electric dryer to dry injera, but it's common to dry injera in open sun drying in our society, and it's called Dirkosh. However, this method suffers from many drawbacks, which are presented here. It's vulnerable to contamination by insect and fungus. There is no control over the final moisture content of dried injera. It's also labor intensive and demands large area. There are many studies conducted in this solar drying area, and many authors designed and evaluated different solar dryers for drying different foods. There are also studies that show the economic benefit of using solar dryers. However, there are no studies conducted to evaluate the performance of solar dryer for drying injera specifically. Also, there are very limited studies were conducted to improve the non-homogeneity of drying air distribution in the drying chamber. So based on this research gap, the objective of this study will be presented next. The first objective is to experimentally investigate the performance of modified mixed mode solar injera dryer. The next is to improve the non-homogeneity of drying air distribution through the drying trees. Finally, to perform economic analysis of this modified mixed mode dryer by comparing it with these electric dryers. This is the image of this modified mixed mode solar injera dryer. As you can see, the vertical distribution channel is integrated inside the drying chamber to facilitate uniform air distribution through different drying tree positions. The methodology followed in this study are classified into two. First, different flow parameters were measured in 5-minute interval. Simultaneously, the weight of injera were measured in 30-minute interval, and based on this testing result, the performance of the modified mixed mode solar injera dryer is evaluated by using energy and exergy analysis, and then economic analysis also conducted finally. By doing so, different assumptions were imposed. This is the experimental setup and data collection setup of the overall testing process. Here you can see that different equations used to evaluate the performance of the dryer, including the economic analysis of this modified mixed mode solar dryer. So the result from this experimental study are presented from now on. So this figure shows the drying curve of injera. As you can see that the moisture content of injera from 1.9 grams of water per grams of solid decreased to 0.14 grams of water per grams of solid in 4-hour time interval. So this shows that the drying process takes only 4 hours. And also the performance of the dryer shows that the specific energy consumption and the drying efficiency were evaluated and evaluated to be 6.9 kilowatt per hour per kilogram and 10% the drying efficiency. So this shows that specific energy consumption was somehow higher, which shows that if the dryer were loaded in its full capacity, which is 10 kilogram of injera per batch, so we can achieve a lower specific energy consumption, which also increases drying efficiency. Here we can see the temperature distribution through the drying trees. As you can see that the collector outlet temperature, which is the drying air temperature, was higher throughout the drying period, above the ambient temperature by 10 degrees Celsius. And also you can see the temperature distribution through the drying trees. The bottom 4 lines shows that one, and the maximum difference between this modified mix the drying trees were found to be 2 degrees Celsius, which indicates that almost uniform temperature distribution were achieved throughout the drying trees. Here we can see the exergy flow diagram of the drying chamber. As you can see, the exergy outflow was lower initially, or the first half of the drying period, which indicates that the exergy into the drying chamber were consumed to raise the temperature of the injera and the drying chamber walls from the ambient. But after 12:30 it starts to increase, while the exergy inflow and the exergy loss of the drying chamber was decreasing. This indicates that the drying wall was providing energy to the drying air, so that energy was manifested as a higher exergy outlet at the outlet of the drying chamber. Here, as the exergy outflow increases, the efficiency of the dryer by the same time, which is after 12:30, starts to increase, and this shows that they have a direct correlation. But here also exergy loss is decreasing. From the economic analysis, we can see that to dry 509 kilogram injera per year using solar dryer will have annual cost of 2,466 Ethiopian birr. But if you use electric dryer, it is about 3,400 Ethiopian birr. As you can see, using solar dryer can improve the annual cost of drying 500 or drying injera by 40%. Next, we can see the life cycle savings. Here, the saving per day due to using solar dryer is 111 birr when it's compared to this electric dryers. Also, the payback period of the dryer is found to be 0.5 years. Here we can see the exergy diagram of the modified mixer mode dryer. Here also, as you can see, the inlet exergy of the drying chamber was the sum of the collector outlet exergy and the solar radiation, which is penetrating the drying chamber through the drying chamber top cover, which is transparent top cover. Finally, we can see that the injera before drying is this one. So after drying, it's turned out to be like this. So based on these results, we conclude that the modified mixer mode dryer performance was higher than open sun drying due to the higher drying air temperature. Also, the quality of dried injera in this modified mixer mode solar dryer is better than open sun drying. Also, uniform temperature distribution was found throughout the drying trees, which is the result of this vertical air distribution channel, which is integrated inside the dryer, which maintains uniform temperature distribution throughout the drying trees. And also from the economic analysis, it's found that the society will benefit if it is adapted and this modified mixed mode solar dryer will create income generation system for the society and for the government also, and it improves the value added food products of the country, which is integrated into this foreign exchange opportunity of the country, because if in good quality, if injera is dried in this good quality, so it can be exported throughout the world. Finally, we present some recommendations, future workers. The quality standard of dried injera should be researched, including the moisture sorption isotherm, and the performance of the dryer should be measured in a full load, improving the solar dryer by adding backup heat storage, which can facilitate to use this dryer in the night time when there is no solar radiation, which results higher productivity. Also, the society should be informed about solar injera drying through different research and medias to increase their awareness. So EAI ICAS 2021 will be the first one to introduce to society, and such medias will have important such events will have important contribution in informing the society and introducing this drying technique to the society and to the government also to implement it. Thank you. If there is any question.